Okay, so let's finish off the last few questions for Prep Test 9, Game 2. Um, we left off on number 11, so let's start there. Number 11 says if M is not selected to attend the retirement dinner, then um, the four people selected to attend must include which one of the following pairs of people. So they're telling us that, put M out and then pick the answer choice that has a pair of people in it who would have to be in. Okay? So we're going to have to know that at least two people are in. So let's just start by putting M out, right? And when M goes out, we'll notice that whoever, like the J and K and the N and P are already represented on this board. So the spaces that they are going to take up are already taken up. We just haven't placed them exactly. Now the M is out. So who do we have left? We have L and Q. So L and Q are going to have to go in. Okay. So we put L here, we put Q here. Okay. And some people might look for the answer right away, and that there's no problem with that. You wouldn't. I don't think you would find it yet because there's one more piece of analysis to do, which is that since the Q is in, then we know that this rule says that K has to be in. Okay, so we can actually say this, and then we know the J is out. At this point, we don't know anything else, so we would then look at the answer choices and look for the pair of people who have to be in. The possible answers would be KL, KQ, or LQ. Any of those would be fine. When we look at the answers, we see that B, K, and L is the one that they gave us. And when we look at the wrong answers real quickly, if we look at A, A has J in, but we know that J can't be in, so that's out. And then the bottom three, C, D, and E, they all include either a P or an N. And what we know from looking at this here is that we don't know whether the P and N are going to be in or not. So we can't say that they for sure are going to be part of a pair that's going to be in because we don't know that they're going to be in. All right? That's not too bad of a question, I think. Let's go to number 12. So number 12 says, actually, let me get rid of this work here. All right. Number 12 says, if P is not selected to attend the retirement dinner, then exactly how many different groups of four are there, each of which would be an acceptable solution? So P is not selected, and then they want to know how many solutions we can come up with. So let's go ahead and do the P not selected. So P's out, okay, which means N is in. And then let's see if there's any other analysis we can do. And indeed, this rule over here says that if N, then L. So since we put N in, we have to put L in. And now, again, we're in the same situation where there's just two variables left that are not represented on the board, and there's two spaces, so we can do a dual option for them. So we're like Q slash M and Q slash M. And now we just want to try to count the number of solutions that could arise from this. So if there were no other rules affecting this at all, then we would say that there would be four possible solutions, right? We could do the J with the Q, the J with the M, the K with the Q, and the K with the M. But the problem is that not all of those solutions abide by the rules. In particular, right, the Q being in requires the K to be in. So we can't go JQ because if we put the Q in, we can't select the J, we have to select the K. So the JQ is out, but we can still put the J with the M, or we can put the K with either the Q or the M. So there are three possible solutions, and that would be the answer here. But I do think that a lot of people might make a mistake and choose four because they didn't look carefully enough to see that there's one of the solutions that looks like it could work that actually violates a rule. So the answer here would be C. So let's look at the last question, number 13. Um, this question is This question is one where they want us to figure out which of the answer choices would then allow us to completely determine the complete solution of who's going to be selected, right? So they're like, okay, we're going to give you two people in each answer choice, and what we want to know is when you select which of these two people, when you select them, right, would lead to the solution being completely determined. So before I do these questions, I like to think about, all right, what is it that is still on the board and left for me to determine, so I can kind of pay attention to whether the answer choices would straighten all of those things out. So here we need to straighten out a lot, right? We need to figure out whether it's going to be the J or the K. We need to figure out whether it's going to be the N or the P. And then in the three remaining spots, we have the variables Q, L, and M that are going to go into those three spots, one of which is out and two of which are in. So I should say, for the two remaining spots that are in the in group, we need to figure out which one of the three variables that are left, Q, L, and M, is going to go, which pair of those three variables is going to go in the in group. Okay, so we need to straighten all of that out. If you don't straighten all of it out, it can't be the answer. So let's look at A. And you may have, again, I say this a lot, you may have some intuition about what the answer could be, and if you do and you go straight to it, that's great. But I'm going to be a little bit more methodical, and if anything, I'll discuss the intuition afterwards if there is one. All right, so A is J and L. So that straightens out the JK, obviously. We would put J in and K out. But then the fact that we choose the L, does that dictate to us anything about the N and the P? And the answer is no. And so right away, then we know that that can't be the answer. Okay? So we look at B and it says K and M. So choosing the K will straighten out the JK, right? So the K will go in, the J will go out. And choosing the M really doesn't do that much for us at all. I mean, we know that either the M or the Q is going to be in, and either the M or the Q is going to be out, but we don't know for sure which one it's going to be, so that B cannot be the answer either. Now we look at C, which says L and N. So we choose L and N, and that's fine. The P goes out, but that doesn't tell us anything about whether the J or the K is going to be chosen, right? It also leaves room for the Q and the M to still move. So the L and the N actually leave a couple of things undecided, so that can't be the answer. D says L and Q. So if we choose the L and the Q, okay, we are still left to decide. So the Q being in would dictate that the K had to be in. So if we go, I'll just draw this one out since it's slightly more enticing, but it's still wrong. It's slightly more enticing than the other one. So we said we said the L and the Q. So we put the L here, we put the Q here, right? Now the Q being in dictates that the K is in fact going to be in. So the K is going to go in, and then the J is going to be out. But we still have, and then so we also know, I should just be complete, we also know the M is going to be here. But we cannot resolve the issue of whether it's going to be N or P. All right, we have no way of resolving it. Now some people might get confused with this rule and might think the fact that the L is in means that the N has to be in. That would be reading that rule backwards, something that hopefully you are well trained to avoid by now. But so the point is that we don't know whether it's going to be N or P. So this also can't be the answer. So hopefully E is going to be the answer. E says M and Q. Okay, so this indeed does look promising, because if we put the M and the Q in, the Q dictates the K, and then the fact that the L is not in dictates that N cannot be in, so we would have to choose P. Let's go through that real quick. They're telling us to put Q and M in. So we put Q and M in, that would mean that L is out. Okay, and then there's just two rules that we have to apply to straighten out the J versus K and the N versus P. One of the rules is that since Q is in, then we know the K has to be in, so this has to be K. And then we also know that because the K is in, the J is out, obviously. And then finally, the contrapositive of this rule, okay, says that if L is not in, then N is not in. So we know L is not in, which means N cannot be in. So this would have to be the P, and then this would have to be the N. So indeed, by putting the Q and the M, by telling us that there was the Q and the M that were in, that leaves us with only one solution, which is what they mean by completely determined. So E would be the answer here. All right. This is a good example of an in and out game. I think if you're just getting started with these games, the one thing that you really want to focus on here was this part. The fact that when you get a rule that says if that exactly one of J and K are going to be in, or exactly one of N and P are going to be in. And this applies only in and out games, okay? Other ideas that are similar apply to other games, but the specific version that I'm saying here applies only to in and out games. Okay, when I tell you that one is going to be selected from a pair of variables, then the thing you should do is write, okay, well, I don't know which one is going to be selected, but either J or K is going to be in, and either J or K is going to be out. and the same thing with N and P. I think that's the big takeaway if you're just getting started. Um, the other thing here is that you can see there's a lot of conditional reasoning, and you need to be able to handle those kinds of statements when you're doing in and out games and when you're doing grouping games generally. Uh, of course, linear games also, but especially so in grouping games. So conditional reasoning. Okay, see you in the next video.